Hi, this is Mrs. Vrobel. This is Chapter 11, Part 3 of Stoichiometry. So in this video, we're going to learn how to identify a limiting reactant, and then we're going to correctly identify the excess reactant and find out how much is left over after the reaction. And then lastly, we're going to calculate the mass of a product when you have two different amounts given for individual reactants. Okay, so in this recipe, and I'm not trying to get you hungry, but notice that we have a hot fudge sundae, and when you're looking at the recipe, there are certain requirements with that recipe. So here we have 2 scoops of ice cream, 1 sherry, and 50 mils of syrup. For this sundae, that is the specific amount. Now here we have a bunch of ingredients, and we need to figure out how many sundaes can we make. Now notice there's 1, 2, 3, 4 sets of ice cream. There's 3 sets of cherries. And then there's only 100 mils of syrup. So the question is, how many sundaes can you make from these 3 sets of ingredients? Now, if you listen to what I was saying earlier, there's only 100 milliliters of chocolate syrup. So as a result, you can only make 2 sundaes. There's plenty of cherries. You can make 6 sundaes. And here you can make 4 sundaes with these ice cream scoops. But because the chocolate syrup only has enough for 2, that's what the limiting reactant is. Okay, so here we have 2 substances. We have 6.7 moles of hydrogen and 3.2 moles of nitrogen, and the question is, which is the limiting reactant? The quickest way to do this type of problem is just to look at the mole ratio. So you want to take the moles of the reactant that they give it and then calculate moles of product. So you might want to notice here that we have 3, an understood 1, and a 2. So we're going to use mole ratio to tell us with the 3.2 and the 6.7 which one is the smaller amount. Okay, so in this first step here, we took the 6.7 moles and we multiplied it by mole ratio. And notice we get 4.47 moles of ammonia. Here we take the second reactant and we use mole ratio. Notice it's a different mole ratio, and as a result we get 6.40 moles of product. So which one is the limiting reactant? It has to be hydrogen, because hydrogen produces the least amount of product, and that's how we know what is the limiting reactant. Okay, so here's a jar of hydrogen and nitrogen, and notice I have 1, 2, 3, 4, 5 molecules of nitrogen. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 molecules of hydrogen. Now, we need a certain amount of hydrogen. Notice we need 3 molecules of hydrogen for every molecule of nitrogen to get ammonia. So we have 1, 2, 3, 4, 5 possible products. Notice that they have to group themselves in a certain ratio, and that's what happens when you have reactants forming products. So here we have 1, 2, 3, 4, 5 sets of ammonia molecules with 2 molecules each for each reaction. Now, if for some reason you have an excess, okay, notice that we have extra nitrogen. Notice that there aren't enough hydrogen around to give us more products. So as a result, we just have some nitrogen lying around, not reacting with anything. Okay, so these are the type of problems that you're going to see with limiting reactant. Here it's just moles. Eventually we'll work towards mass. So here we have 5 moles of hydrogen and 5 moles of oxygen. So we have an even amount. And the question is, how many moles of water could be formed? Well, the first thing is we need a balanced chemical equation. So here's our balanced chemical equation. And then we're going to use mole ratio to tell us which one is smaller. Now, my question to you is, which one do you think is going to be smaller? Okay, so here we have 5 moles of hydrogen, and notice that this is essentially 1, and we get back 5 moles of water. Here we have 5 moles of oxygen, but now we're doubling it because we have 2 moles of water with every 1 mole of oxygen. So notice that we have even more moles of water. So which one is the limiting reactant? It has to be hydrogen, okay? So hydrogen is the limiting reactant. Okay, and then lastly, we have mass. So the previous problem we had moles. This one we have mass. And notice we have 10 grams of hydrogen and 160 grams of oxygen. And once again, they want to know what is the mass of water to be formed. So the first step is you're going to convert the the mass of hydrogen to moles of hydrogen by dividing by molar mass. And then you're going to multiply it by mole ratio. And then after that, you're going to multiply it by molar mass of the product to give you the mass of water. Now, you would do the same thing with oxygen. So notice you have more oxygen in mass. It makes sense because it weighs more. And then you're going to divide it by the molar mass, multiply it by the mole ratio, and then multiply it by molar mass of water to give you 180 grams. So once again, the limiting reactant is hydrogen. Okay, so how do you determine the limiting reactant? You first want to determine the mass of one reactant, and then you're going to use the mole ratio to help you figure out which one is smaller. So you're going to take the mass of one reactant and compare it to the other, and you're going to find which one produces the least amount of moles. And once you figure out which of the two is the limiting reactant, you want to take that amount and then convert it into mass of product. And that will be the maximum yield of that reaction. Okay, so in summary, the limiting reactant is never in excess. It is always used up for the whole reaction. So the excess reactant always has some kind of leftover. So in the limiting reactant, we're looking at mole ratio, and whichever reactant produces the least amount of product moles tells us what is the limiting reactant. And then after that, we can either calculate the maximum yield or the theoretical yield, and we can also subtract, and we'll do this in class where we turn it over to decide what is the amount left over of the excess reaction.